type questions that were generated by Delta Math. So yours may not have been this exact question. Everybody had the same type of question, but the numbers were different. So this one was just classifying the triangle, determine the type of triangle. And it was multiple choice. So you were choosing, and they have them based on angle and sides. Remember, when we talk about angle, we're talking about obtuse, right, and acute. So an acute triangle, all three are acute. In a right triangle, you have one right, which this example happens to have a right angle, a 90-degree angle. So this is a right triangle. An obtuse triangle would have one obtuse angle. So this one's a right triangle. And then looking at the side lengths, they're all different. You can also look at the angles to determine this. All the angles are different. So it's scalene, because all three are different. So this is a right scalene for this one. Yours may have been different. So, but it was just a classifying question. And if you are struggling with that, that was back in, I think, 4.1. You can go back and look at your 4.1 notes, which was classifying triangles and triangle sum theorem. This one is listing the angles from smallest to largest. This is the hinge theorem. Like I showed y'all a visual of opening a door. The hinge connects the door to the wall. So as the door opens, the angle gets bigger, and so does the distance from the door to the wall. So the longer side is across from the larger angle, and as the door closes, the angle gets smaller, and so does the distance, which represents the length of the triangle. So the shortest side is across from the smallest angle, and the longest side's across from the largest angle. If you can't visualize it, draw it. They don't give you a picture, give yourself a picture. And it doesn't matter how you draw it. It does not have to be to scale. So if they say we have triangle EFG and F to G is 17, G is 18, and E to F is 19. So the smallest angle is going to be across from the shortest side. So 17 is the shortest. So angle E is the smallest. So angle E, nope, 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 nope. Yes. So I've already eliminated all but two answer choices. Okay, and then you can go to the middle next, or you can go to the end, it doesn't matter. But the medium length, the one in the middle, is 18. So it's across from the middle sized angle, which would be F. So nope. That one has it right, but we already know that's the wrong answer. That one has it right. And then I know we've eliminated all the answer choices but the right one, but just to double check, the longest side is 19. So it's across from the largest angle. So G is the largest. The only one that has all three of those in the correct position is this one. All right. Then I went over this in another video. This is triangle inequality theorem. Remember, the theorem says that the two shortest sides of a triangle, and I should say the sum of the two shortest sides, must be greater than the long side, or the third side. So I'm going to test all of these answer choices. I'm going to find the two shortest. They happen to have theirs in order, so that's nice. They put the shortest ones next to each other. So you add up the two shortest sides. So 9 plus 24 would be 33. 10 plus 23 would be 33. 9 plus 14 would be 23. And 14 plus 20 would be 14 plus 26 would be 40. Okay, and then you're comparing it to the longest side, which is the one we didn't circle. So I'm just going to set up these comparisons so you can see it. And then we want it to be greater than. I'm going to write a greater than, equal, or less than symbol. These are equal. This is less than. This is less than. This is greater than. So the only one that is greater than is this one. All of the others can't form a triangle because the two shorter sides don't add up to be greater than the third or the longest. Let's see, 5. All right, so we're looking for the measure of PQO. So P to Q to O is this angle up here. And then we are given these tick marks. These mean congruent. So this is an isosceles triangle. So in an isosceles triangle, you're used to seeing the isosceles triangle drawn with the legs here and the base at the bottom. And so then you know that the base angles are congruent. Well, this one's just turned to where the vertex angle is where the congruent sides meet. Here's my vertex angle. It's just rotated to the side. So my base angles are here and here. So that's just 52. There's nothing to calculate. It's just knowing about an isosceles triangle. All right, this one says a side of a triangle below has been extended to form an exterior angle. Okay, some of y'all are not remembering the exterior angle theorem. The exterior angle theorem says that the exterior angle formed by extending one of the sides of a triangle, so this is the exterior angle, is equal to the sum, which means adding the opposite to interior. And I guess instead of just some squiggles, I could put some numbers there. So 1 plus 2 would equal 3. So the two interior angles opposite that exterior angle have to add together to equal the exterior angle. That's the exterior angle theorem. So in ours, they say the exterior angle here is 53. So 53 should be the sum of these two angles. Well, this is 90. So x plus 90 equals 153. You could actually set that up as an equation, or most of you would just say, okay, the total minus what I've used to see what's left. And that's the math that you would be doing if you set it up as an equation as well. It's just, do you want to write it as an algebraic equation, or are you just going to do your math like this? Either way, you get 63. So that angle was 63 degrees. And you can check 63 plus 90 does equal 153. Okay, then 7. These are mid segments because it tells you that triangle OPQ. So OPQ, this triangle here in the middle, is formed by connecting midpoints. So that means that P, Q, and O are all midpoints. So when you connect midpoints within a triangle, you are drawing mid segments. So each of these is a mid segment. And we learned in 4.5, if you need to look back to your notes, that mid segments are parallel to the third side of the triangle, side they don't intersect, and have that length. And we also learned that because they're parallel, so for instance, QP is going to be parallel to LM down here. So if you remember parallel lines and transversals, you're going to have corresponding angles. So 54 would correspond here to 54, for instance. Okay. It's also going to correspond here. We said that the mid segments create 4 triangles that are all congruent. And so like the bottom right corner of those outer 3 are going to be 54. And since the bottom left is 80, this bottom left will be 80, and this bottom left will be 80. And since this top angle is 46, this top angle will be 46. This top angle will be 46. So you can see these outer triangles are all identical. They're even drawn in the same orientation. The only one that's different in orientation is that middle one created by the three mid segments. And it's also congruent. It's just rotated 180 degrees. It's upside down. So instead of that blue angle being at the top, it's at the bottom. And instead of that red angle being on the left, this is rotated upside down. So the red one's here. The black one's here, the 54. Okay, so that's how you know the angle relationships created by those mid segments. Now, if that is too confusing, you can also do the tick mark method that I showed you, which I said just write the tick marks for the congruent sides. So QP is going to be congruent to half of LM, so LO and OM. So those three have one tick mark. PO is going to be congruent to QL and NQ. QO will be congruent to PM and NP. And if it's easier for you to find the congruent angles where the tick marked sides meet, so for instance, the 54 is where the red and blue or the 1 and 3 tick mark meet. Everywhere 1 and 3 meet is 54. Those are all going to be the same. So for some people, that's easier. So I could color code those angles like that. But say the 54 is going to be those. But say the 46 is where the 2 and the 3 tick marks meet. So everywhere the 2 and the 3 tick marks meet, that's going to be 46. And everywhere that the 1 and the 2, or mine are the red and the green, everywhere those sides meet is going to be 80. So you could do it that way, whatever floats your boat. Okay, but this question is asking us to specifically find the measure of LQO. So L to Q to O is this angle here, which my color coding I did highlighted in green. So the 46 is what it's congruent to. So that should be 46. So I didn't have to do all of this for this one particular problem. I was just reviewing the concept with you. All right, another mid segment. Now this one's not about the angles. This is about length of the segments. Not only are these that are parallel going to be parallel to each other, the mid segment is half the length of the side length it's parallel to. So IJ is half of FG. What? Or you could think of it in reverse. You could say FG is double IJ. I prefer that one. I don't like to deal with the half. I'd rather double things than cut them in half. I think that's easier, but you can do what you want. And they tell you, oh, this one is angles. Oh, well, that's true. What I just told you is true, but we don't need it for this problem. This one is HGF. It's this angle here is 8x plus 36. And HGI, or excuse me, HJI, this angle here is 3x plus 66. What's the measure? Well, we just got through talking about in the last one that those are corresponding angles. Okay, those would end up being the same color if I color coded, because these are parallel lines. The mid segment is parallel to the third side. And then if you look at, this is the transversal, those are corresponding angles. So those are congruent. Congruent means equal. So I'm going to set them equal. So I'm going to set 8x plus 36 equal to 3x plus 66. And then I'm going to solve. So I'm going to get my x's to one side with opposite operation and my constants to the other. Divide out the coefficient. Now the question didn't ask for mistake a lot of people are is stopping too soon. Your answer is not 6, x is 6, but the question asked for HGF, which is the red one. So I'm going to take it and plug that x back in to 8x plus 36. So I'm going to do 8 times 6, which is 48, plus 36. So that comes out to 84. Now, it really doesn't matter which one they asked for. They should be the same. And you could check it by plugging it into this one as well and making sure that it also comes out to 84 because they are supposed to be congruent. And it does. Okay, so your answer there was 84. Yours may have been slightly different, but it's the same concept. All right, almost there. All right, this one's mid-segments again. Oh, this one is saying triangle ST is formed by connecting the midpoints. Okay, so those are mid-segments. The measure of the interior angles of PQR shown. Find the measure of QTS. So QTS here. So if you want to do it with the tick marks, go put your same number of tick marks on your different sides to help you see, hey, that angle is where a 2 and a 1 tick mark side meet. So everywhere a 2 and a 1 tick mark side meet is going to be the same. So those 4 red angles are the ones that are congruent to each other, and one of them is marked 41. So this one must also be 41 degrees. So why that's showing up purple. All right, I think this was last but not least. These I'm gonna ask about side lengths. And maybe it was a mix, and the ones I just screenshotted happened to all be angle ones. But if some of these with mid segments were about side lengths, it was like what I started to show you here, that the mid segment is half the length of that parallel side, or the parallel side is double the length of the mid segment. And that's how you would set those up if you had anything like that. And if you do watch videos, when you're actually in Delta Math, you can watch some of those and you can view examples as well. And you can view multiple examples. So if one's an angle and you need to see a side length one, just go next example till you get one that's about side lengths. Okay, so this one is an angle bisector because it's bisecting this angle. That's what these markings up here in the angle mean, that these are equal. So S is being bisected by ST. But then down here at the bottom, we also have tick marks on the segments. So it is also bisecting QR. So it's an angle bisector and it's a segment bisector. So this was asking you to select all that apply. So it is an angle bisector. It is a segment bisector. And let's read these others. S is the vertex of 2 angles that are congruent. Yes, because now this little angle is congruent to this angle. So QST and TSR. So that one's true as well. S is the midpoint of a segment. No, S is not a midpoint. It's a vertex. So no. T is a midpoint. Yeah, because this is bisected. So T is the middle. It is the midpoint of QR. So that is true. And none of the, we already selected, so it would be those. So it just depends on what picture you were given. Some of them you were given without those angle markings, so you can't say it's an angle bisector. Some of them you were given a 90-degree angle marking, so you know it's a perpendicular bisector, or you know it's an altitude if it comes from a vertex. So it just depends on which graphic you were given and what markings were there. Okay. I think that's everything, because I already went over in the other videos the teacher created problems. Yep, that's it.